You are standing outside on a clear night. You look up. You see a faint blue dot near the horizon, one you were told is Uranus, one of the quiet giants of the solar system. It looks harmless. It looks impossibly far away. But the real answer to what would happen if that quiet giant came straight at you is far stranger than anything in a disaster movie. Uranus is not small. It is 14 times heavier than Earth. It is wrapped in a thick atmosphere of hydrogen, helium, and methane, the gas that gives it its pale blue-green color. Now imagine that entire world, 64 times the volume of Earth, moving toward you at 1,000 kilometers per second. That is more than 3 million kilometers every hour. That is roughly 3,000 times faster than a commercial jet. At that speed, Uranus would cross the distance from the Moon to Earth in about 6 minutes. Your brain cannot really picture that speed. Nothing in your daily experience moves anywhere close to it, so let your body imagine it instead. By the time you saw Uranus as a distinguishable disk in the sky rather than a point of light, you would have less than an hour left. By the time it filled half the sky, you would have seconds. There would be no slow, cinematic approach. There would be a normal night, and then there would not be a night at all. Long before impact, something else would happen first. You would never actually feel the collision because you would already be gone. At 1,000 kilometers per second, the shock wave through Earth's atmosphere would outrun any warning your senses could register. Sound moves through air at about 1/3 of a kilometer per second. Uranus would be moving 3,000 times faster than the sound of its own arrival. The sky would still look calm in the instant before it stopped looking like anything at all. To understand why this matters, you have to understand what a collision like this actually is. It is not really an impact in the way you think of a car crash. It is an energy transfer problem. Physicist and geologist H.J. Melosh, who spent decades studying impact cratering at Purdue University, showed that the damage from a collision does not scale with how big the object is. It scales with how fast it is moving, squared. Double the speed, and you do not double the destruction. You quadruple it. At 1,000 kilometers per second, you are not looking at a bad day for the planet. You are looking at the complete unmaking of it. Compare this to something you already know. 66 million years ago, an asteroid about 10 kilometers wide struck what is now the Yucatan Peninsula in Mexico. It was moving at perhaps 20 kilometers per second, slow by cosmic standards. That single impact ended the age of dinosaurs. Geologist Walter Alvarez and his father, physicist Luis Alvarez, first proposed in 1980 that a layer of iridium found in rock all over the world was the fingerprint of that impact. A rare metal common in asteroids, but rare on Earth's surface. Later, geophysicist Alan Hildebrand helped confirm the crater itself, buried under the Gulf of Mexico, over 180 kilometers wide. That was one small asteroid at a fraction of the speed. Uranus, at 1,000 kilometers per second, carries roughly the same combination in a completely different category. It is not a rock the size of a mountain. It is a planet the size of 4 Earths side by side, moving fast enough to make its own physics. Here is where the story gets stranger than a simple ending. Earth would not really be destroyed in the way an asteroid destroys a city. Earth would be disassembled. On contact, the kinetic energy involved would instantly vaporize rock, not melt it, vaporize it. Silicon, iron, and oxygen, the elements that make up the ground beneath your feet, would turn to superheated gas and plasma within moments, faster than the eye could track. The temperature at the point of contact would briefly exceed the surface of the sun. Two planetary bodies would essentially become one expanding cloud of debris and vapor, its material eventually spreading out into space, some of it possibly forming rings or moons the way scientists like Robin Canup have modeled for the moon-forming giant impact that struck early Earth over 4 billion years ago. That earlier impact is worth pausing on, because you are, in a strange way, already a survivor of one. Planetary scientists widely support the idea that a Mars-sized body, sometimes called Theia, struck the young Earth roughly 4.5 billion years ago. That collision was violent enough to melt the planet's surface and fling debris into orbit, debris that eventually became the Moon. Canup's simulations, developed at the Southwest Research Institute, showed how such a collision could produce a moon with almost the same composition as Earth's mantle. You look up at the moon most nights without a second thought. It is the leftover wreckage of an ancient planetary collision, one much slower and much smaller than the Uranus scenario, and it still nearly tore the young Earth apart. So why does this thought experiment feel important? Because it forces you to confront just how fragile your sense of permanence really is. You walk on solid ground, you trust gravity to hold everything down. You assume the sky stays the sky. But the difference between a stable solar system and a catastrophic one is often just speed and timing. Uranus, in its actual orbit, poses no threat to you at all. It orbits the Sun once every 84 years, calmly, predictably, at a safe distance of billions of kilometers. The scenario of it striking Earth at 1,000 kilometers per second is not something astronomers worry about. It is a thought experiment, a way of using an impossible number to make an abstract idea, kinetic energy, feel real in your body. And that is the real twist hiding inside this question. You already live your whole life surrounded by forces at this scale. The Sun converts 4 million tons of its own mass into energy every single second through nuclear fusion, and you feel that as nothing more than warmth on your skin. Astrophysicist Carl Sagan often pointed out that the numbers involved in cosmic events are so large that human intuition simply breaks down trying to hold them. Your brain is built to judge the speed of a thrown rock, not the speed of a planet. That gap between what you can imagine and what is physically true is exactly where wonder lives. There is something else, too. When you imagine Uranus crashing into Earth, you are really imagining an ending. But look again at what actually happens in these collisions. The dinosaur-ending impact did not simply erase life. It cleared space for small mammals, your distant ancestors, to survive and eventually dominate. The moon-forming impact did not simply damage early Earth. It gave the planet a stabilizing moon, one whose gravity locks Earth's tilt in place, keeping the seasons regular enough for complex life to evolve at all. Destruction, on a planetary timescale, is rarely just destruction. It is redistribution. Matter does not disappear. It changes shape, changes location, and sometimes changes into something that makes the next 4 billion years of life possible. You can hold both of these truths at once. Earth is staggeringly fragile, one badly timed orbit away from unraveling completely. And Earth is staggeringly resilient, built from the wreckage of collisions that should have ended everything and somehow did not. Every atom of iron in your blood, every trace element in your bones, was forged in the collapse or collision of something far larger than you can picture. You are not separate from these violent cosmic events. You are their long-term result. So the next time you look up and see that faint blue dot near the horizon, you are not looking at a threat. You are looking at a reminder. A reminder that the line between annihilation and creation, on the scale the universe operates at, is thinner than you think. A reminder that the world under your feet, solid as it feels, was built by catastrophe long before you arrived to take it for granted. Tonight, when you look up at that same sky, you will not just see a distant, harmless point of light. You will see the version of the universe where you survived.